Okay, so today we're going to focus on physical properties of different molecules and compounds. And these physical properties that we're going to talk about are all due to the strength of the intermolecular forces, or the attraction between the molecules. And the properties we're going to touch upon that are directly related are phase, okay, if something's a solid, liquid, or gas. Okay, if you have stronger intermolecular forces, it tends to be a solid at room temperature. If you have very weak intermolecular forces, it tends to be a gas at room temperature. Okay. Along with that goes along with phase, is melting point, boiling point. The stronger the interactions, okay, the higher the melting point, the higher the boiling point temperature. Okay, so these two go hand in hand. Surface tension. The stronger the attractions between particles, the higher the surface tension. Same thing with viscosity. The stronger the attractions, the more viscous the liquid is. And if it gets to be a certain point, it'll be a solid, okay, if the attractions are so strong. So these four are directly related, okay, directly relating, meaning as the intermolecular forces increase, okay, or the strength of those intermolecular forces increase, these four characteristics are directly related. Okay, melting point and boiling point goes up, surface tension goes up, viscosity goes up. The only one that doesn't is vapor pressure. And we're going to explain all these things. But as intermolecular forces increase, vapor pressure actually decreases. Okay, so it's the only one that has an inverse relationship. Okay, so what we're going to do is take each one of them and talk about them. And we'll start with phase. Okay. So remember, the stronger attractions you have between particles, like here we are showing a hydrogen bond between two water molecules, they result in the particles being closer together, organized, and they are more solid. Okay, the stronger attractions you have, it makes it harder to change phase. Okay, now what happens? Well, if you have strong intermolecular forces, you have higher melting points and freezing point temperatures. Going back to, states of matter, the molar heat of fusion, okay, the amount of energy it takes to melt something is higher. Okay. Also, same thing with the molar heat of vaporization, or the heat of vaporization. It takes a lot more energy to vaporize something that has stronger intermolecular forces. Okay, so viscosity is a physical property, okay, and it's usually in terms of a liquid, but it's measure of the resistance to flow, okay, and it usually is like a little mu symbol. The stronger the attractions, the more viscous the liquid. If that viscosity gets so large, it is a solid, okay? So it's the resistance to flow. So this just shows you something with low viscosity, which would have weak intermolecular forces, something with high viscosity, like molasses or syrup, that has really strong intermolecular forces. Okay, now vapor pressure is something that can confuse people, okay, and it's the only inverse relationship, meaning as the intermolecular forces increase, vapor pressure decreases. Okay, so what happens is gas molecules, or molecules that evaporate in the liquid, go into the gas phase. Okay, they evaporate and they're in the gas phase. And then they collide with each other, they collide with the walls of the glass or the container, and they create their own vapor pressure. Okay, if you have strong attractions in this liquid here, there's few molecules that are going to escape into the vapor phase, which is why the vapor pressure would be lower. Okay, so let's look at another picture just to make sure it's clear. Think about water, okay? Little gas particles will escape, okay? They will start hitting the walls, hit each other, and they create their own vapor pressure. Okay? If the intermolecular forces are really strong, there'll be very few particles up there. Okay. And one thing that's important to understand is the temperature increases, vapor pressure increases. So that's a direct relationship. You can increase the vapor pressure by increasing the temperature. Okay. We're going to touch briefly about phase diagrams. Although you don't have to analyze a phase diagram on the AP test, we're just going to look at it and then practice some free response questions about physical properties. Okay, so vapor pressure and phase changes, just a couple definitions. Normal melting point, okay? Normal, remember, means the pressure is 1 atmosphere, okay? Standard pressure. Okay, it's a temperature that a solid melts when the pressure is 1 atmosphere. Solid and liquid have the same vapor pressure, and that total pressure is 1 atmosphere. That's when it melts. Boiling point is the same idea, the temperature that liquid boils when the pressure is 1 atmosphere, and the vapor pressure of the liquid is equal to the atmospheric pressure. That's the normal boiling point. Okay, so let's just talk briefly about phase diagrams from honors. Okay, these types of diagrams are for many different molecules. In honors, we showed you one with carbon dioxide, one with water. It shows the relationship between pressure, temperature, and phase in a closed system. Okay, couple points that are on the phase diagram. The triple point is where the temperature and pressure where all 3 phases, solid, liquid, and gas, exist at once. Okay, and critical point is the set of temperature and pressure conditions where phase boundaries cease to exist. So it's a point above which the liquid and gas phase are kind of blended. The compound has both properties of a liquid and a gas. Okay, now this is just a typical phase diagram just to show you. Again, in the AP course, they expect you to know this from honors, okay, but it shows you your solid phase, your liquid phase, and your gas phase, okay? You have the melting and freezing line, the vaporization and condensation line, and then sublimation and deposition. If you don't remember those 2 words, sublimation means going from a solid to a gas directly, and deposition means going from a gas to a solid. I always remember sublimation because it starts with the letter S, and you start with a solid and go to a gas. Okay, so this is just showing you phase diagram, and it also depends on temperature and pressure. Okay, so what we're going to do now is we're going to pause the video, okay, and you guys are going to take 5 minutes to do this free response question for AP. You're going to look at hydrochloric acid, xenon difluoride, xenon tetrafluoride, and this other alcohol, and tell me which one has the highest boiling point, highest vapor pressure, smallest heat of fusion, most viscous. Okay, based on, you're going to look at these 4 things and determine the intermolecular forces between them, between the same molecule. So an HCl and another HCl, an alcohol and another alcohol, xenon tetrafluoride and another xenon tetrafluoride. And then based on the intermolecular forces, you're going to answer the 4 questions. Okay, so let's take some time and do that now.